Hollow spirals can add a touch of elegance to your next project. They will also make a lot of people wonder exactly how you did it. The theory is quite simple to understand, however, when put into practice, it's a little more difficult than it looks. But if you will follow a few simple guidelines, you will easily be able to mill the style shown here, plus many others of your own design. We'll begin by explaining the basic theory, and then we'll expand on some of the tips and techniques that we of Phantom Engineering have learned the hard way. A hollow spiral is a little deceiving. It appears that a hole was drilled down the center to start with, but you can actually start with solid stock and mill the center out as you cut the spiral. It works like this. Using a long cutter, simply plunge down, making several passes until you have cut to the center of the stock. Now you need at least one other start that also cuts to the center. These two cuts will meet in the middle and automatically mill out the center core. It's that simple. A second technique is to start with a column that is already hollow. There are several ways to do this as well. You could take a solid piece of wood and drill a hole down the center, or you can use a material such as flowstone that can be poured up in a tube with a smaller tube in the center as shown here. Being woodworkers, the first material we all think of is hardwoods like oak, cherry, maple, or mahogany. But there are a lot of other materials that also work very well, which we'll talk about in just a moment. When using wood, you need to be aware of a few potential problems. First, wood has a grain that makes it strong in one direction, but very weak in the other. If you look at this spiral piece, you can see that the grain is now very short. When milling a hollow spiral, you are actually making a large wooden spring which will flex and bend. The softer the wood, the more it will spring. This creates two problems. First, as soon as you cut out the center of the stock, if you have too much pressure from the tailstock, you will compress the spring and the actual path of the cutter will change. If you try to make another pass, it will not cut exactly the same. The second problem is that because the splines are weak and can compress, they will also vibrate and the piece can explode right in the machine, which I guarantee will ruin your day. So for the best results when using wood, remember to use a hardwood, preferably with a closed, even grain like maple. Watch that you don't put too much pressure from the tailstock and mill the last pass very slowly. One way to avoid the problems associated with the grain of the wood is to use a different type of material, such as MDF. This material mills well, and because it has no grain, is a little easier to use. However, the only option that you have when it comes to finishing the piece is to paint it. A new product on the market that we are quite excited about is Environ. It's a new solid surface material that cuts, mills, glues, works, and finishes like wood, but looks like stone. Like MDF, it has no grain and is very strong, eliminating most of the problems associated with wood, but it gives you more options than MDF when it comes to finishing. Currently it is available in 6 different colors. Other solid surface materials are available, such as Corian and Gibraltar. Most of these materials need to be laminated and then milled to a round. Flowstone, on the other hand, can be poured up in a round with a hollow core, eliminating a lot of the work and cost. It's also very strong and heavy. If you use your imagination, you will find other materials that will work equally as well. As we saw when using wood, the spiral cut makes the length of the grain short, which weakens the part and makes it flex like a spring. The best way to add strength is to set the pitch as long as possible. Set the gears for a 12 or 15-inch pitch if you have the 2 times gear set, or to the 7.5-inch pitch if you only have the standard gear set. The number of starts will also determine how strong or weak the part is. As we mentioned before, you need at least 2 starts to hollow out the center. Just remember, the more starts, the weaker the part. You should also try to keep the hollow portion of the part as short as possible. As the splines get longer, the more they will flex and vibrate, and the more likely they are to break. The larger the diameter of the stock, The thicker and stronger the splines will be. However, if you are milling a solid piece of stock, the radius will be limited to the length of the router bit. If you are milling stock with a hollow core, then you can go much larger. To cut through the stock, you can use a straight or spiral cutter up to about 1 inch in diameter. A straight cutter is less expensive but creates more vibration and chatter as the bit cuts the material with a chopping action. A spiral cutter does a better job because there is always at least one point of the cutter making contact with the material, so you have a constant shearing action. It will also lift the chips up out of the groove. We recommend a 2-flute spiral upcutting router bit. Several sizes are available from Magnate. For best results when milling hollow spirals, remember to choose a strong material. Set the pitch as long as possible, use no more than 4 starts, keep the diameter of the stock large, the length of the hollow section short, and use a 2-flute spiral cutting router bit. Following these guidelines, you should be successful on your very first attempt. Using the information we just discussed, let's design a typical sample piece. We'll begin by using hard maple, milled to 3 inches in diameter. Next, we set the spiral drive to a 15-inch pitch and using a 1/2-inch diameter 2-flute spiral upcutting router bit, mill a 3-start hollow spiral approximately 16 inches in length. It's as easy as that. Once you have mastered these basic techniques, you may want to experiment and create your own style. A hollow spiral tends to be a little fragile. Therefore, the order in which you perform certain operations is important. The very first step is to mill the stock round and then sand out any marks left by the router bit. Next, mill all of the accent cuts like circular molding, especially any cut that will be on the spline. And finally, after everything else is complete, mill through to the center on each start to create the hollow center. Now that we've covered the basics, we'll show you how to mill each of these sample pieces, step by step. For the first sample, we started with a solid piece of poplar, 2 1/4 by 2 1/4 by 18 inches long. We set the pitch to 3/4 of an inch using the .25 gear reduction set and the 60-tooth drive gear, and milled the stock round using a 1 1/4 inch diameter surface planing bit. Normally, we would cut off the corners on the table saw first. However, in this case, the blank is small enough that we just milled it round in 2 passes. Notice how the dust collector contains almost all of the sawdust. After the first pass, we used a set of calipers to check the diameter at each end of the part. If there is a difference, you can make a slight adjustment to the bed as shown in the Fast Start training video. With the adjustable bed set level, we finished milling the stock round. This last pass gave us a smooth surface, but we could still see the spiral path left by the router bit. Using 120 grit sandpaper, we sanded out the router bit marks. When all of the marks were removed, we finished sanding with a 220 grit paper. Next, we milled the circular molding at both ends of the workpiece, as well as the spiral decorative cuts. The 4 right-handed spiral accent cuts were milled 8 inches long, with the gear set for a 7.5 inch pitch. We then changed to a left-hand spiral and milled the 4 hollow spiral cuts using a 1/2 inch diameter 2-flute spiral upcutting bit. We plunged the bit down and milled approximately 3/8 of an inch with each pass. When the carrier tray reached the micro switch stops, we plunged the bit another 3/8 of an inch, reversed the direction of the motor, and milled back the opposite direction. We then repeated this process until the bit cut to the center of the stock. This style has 4 starts and only a 7.5-inch pitch. Therefore, you must mill the final pass very slowly to avoid breaking out the splines. You will also want to keep the length of the spiral section short, especially when made out of wood. When the first start is complete, we released the tailstock and rotated the workpiece 90 degrees for the next start. We then repeated the whole process over again until we had completed all 4 starts. The accent spirals cut in one direction and the hollow spirals cut in the opposite direction. We created a basket weave effect. The final step was to sand all of the edges and clean up the part. The next piece we made out of flowstone. The center was hollow, so we needed to make a wooden plug for the live center. Using a surface planing bit, we simply milled the end of a piece of wood round. The diameter of the stock had to match the diameter of the hole in the flowstone. First, we milled the end slightly oversized, and then test fit the piece and made adjustments to the plunge depth until the plug fit snugly. Then we cut the end off and marked the center. This part now slides into the end of the flowstone for the live center. To secure the workpiece at the headstock end, we removed the index drive center and replaced it with a 3-jaw chuck. By closing the chuck, we were able to insert the workpiece into the machine. The jaws of the chuck slid into the hole in the end of the stock, while the live center supported the opposite end with the block we milled to stop the hole. After closing the quick-release stock, we opened the jaws of the chuck to center and secure the workpiece at the headstock end. Using the .25 gear reduction set and a surface planing bit, we milled off about 1/16 of an inch to ensure that the part was round and smooth. We then changed to the 2x gear reduction set and the 32th drive gear to give us a 12-inch pitch for the spiral cuts. We decided to use a dish cutting router bit to mill a wide spiral flat to accent the hollow spiral grooves. When milling hollow spirals, the router generally is set to the center of the workpiece and held stationary with the router stops. After setting the microswitch stops at the desired location, we set the plunge depth for approximately 3/16 of an inch to mill the spiral flats. We then plunged the bit into the material and cut from the tailstock to the headstock end. Actually, it doesn't really matter which end you start milling at when you have the dust collector attached, but for best results, you should remember to turn the shop back on. You can see how the inside corners of the flat have a small radius, which is formed by the dish cutting bit. On this part, we could not index 90 degrees for the next start by releasing the tailstock and rotating the workpiece because we are using the 3-jaw chuck. Instead, we used another method that works equally well. First, we open the split nut and then move the carrier tray 4 inches, which is 1/4 of the 12-inch pitch, or 90 degrees. We then close the split nut to hold the carrier tray in place. By measuring the distance from the end of the top rail or by counting the number of threads on the linear drive screw, you can index for the next start without removing the workpiece from the system. Next, we drove the carrier tray back to the microswitch stop at the tailstock end to begin the next start. We then repeated the same process for all 4 starts of the flat spiral cut. Here you can see all 4 of the spiral cuts. The next step is to mill the hollow pass right down the middle of each of these flats. To do this, we used Magnate's 1/2 inch diameter 2-flute spiral upcutting router bit. Not only does it give us a very clean cut, it also lifts the flowstone powder out of the groove so that the bit doesn't heat up. The machine is already set up to mill the hollow spirals because they are milled in the exact same position as the spiral flats. When milling the flowstone, we milled approximately a 1/4 of an inch on each pass. When the carrier tray reached the microswitch stops, we plunged down another 1/4 of an inch, reversed the motor direction, and pushed the override switch to mill back the opposite direction. We recommend that you lock the split nut closed so that it does not inadvertently come open while milling the spiral and ruin your part. It took us 4 passes to mill through to the hollow core. Using the same indexing technique as we used to mill the spiral flats, we milled the other 3 hollow spirals. We found this material to be extremely strong and decided we could have made the splines smaller so that we could see more into the hollow center. For the next sample piece, we glued up 4 1-inch thick pieces of Environ to make a 4-inch by 4-inch by 22-inch long blank. We then cut off the corners in the table saw and mounted the index hubs as shown here. We then changed to a 1-inch diameter 2-flute straight cutter. Using this cutter, we milled the stock to a round in 1 pass. For best performance, you should only offset this bit approximately a 1/4 of an inch because the diameter is smaller than the surface planing bit. For this piece, it really didn't matter how smooth it was because the surface all gets milled away. Next, we changed to Magnate's 2-inch diameter roundover bit with a small radius at the point. And once again, we centered the bit for milling the spiral. We then set the microswitch stops at each end for the desired length of the rope section. After setting the plunge depth, we plunged the bit into the material approximately 1/8 of an inch short of the final plunge depth and made the first pass. We set the spiral drive to a 12-inch pitch using the 2x gear reduction set and the 30-tooth drive gear. We wanted this spiral to be fairly loose. When the carrier tray reached the microswitch stop, we plunged the router bit down to the final depth and milled the final pass in the opposite direction. Normally we like to mill spiral cuts all in the same direction, but this technique worked well and saved us a little time. To index for the nick start, we first turned off the motor drive and then measured the distance from the carrier tray to the end of the top rail. We then opened the split nut and moved the carrier tray 8 threads, or 2 inches, which equals 1/6 of the 12-inch pitch. We also double-checked the measurement to be sure we didn't miscount the threads. After returning the carrier tray back to the starting position of the rope, we again plunged the bit into the material and milled the second start. We then repeated this same operation 4 more times to complete the rope section. For this piece we wanted to make a 6-start rope and then mill out every other bead. By milling the rope first, the splines are already round before we start milling the hollow section. Next we indexed the part and milled a pass on one side of the bead and then a second pass on the other side of the bead. The indexing procedure is as follows. For the first pass, we moved the carrier tray just 1 thread and locked it in place. This offset the bit just far enough to mill against one side of the bead. Then, using a 1/2 inch diameter 2-flute spiral cutter, we made several passes until we had cut to the center of the workpiece. For the second pass, we moved the carrier tray 6 threads, or 1.5 inches. Remember to turn off the motor drive before you open the split nut and move the carrier tray. If you don't, the motor will rotate the workpiece when you move the carrier tray off the microswitch stop. This second pass mills out the other half of the first bead. For the third pass, we move the carrier tray 10 threads, or 2.5 inches, to begin milling out the second bead. After we had completed this pass, we alternated between 6 and 10 threads for the rest of the splines. This procedure will mill out every other bead, leaving the 3 splines. Here you can see how we milled on one side of the first bead, and then by moving the carrier tray 6 threads, we milled on the side of the second bead. We then indexed 10 threads to set the router bit on the far side of the second bead, followed by 6 threads to begin the next bead, and so on, repeating this pattern until all of the splines were completed. After the hollow portion was milled out, we came back and milled the ends round and dressed up the ends of the splines. For the next sample, we chose to make a contoured profile with a hollow spiral. We began by mounting the template base onto the machine with the hardware supplied with the contour duplicator package. We then inserted a 4.5 inch by 4.5 inch by 24 inch block of MDF, which we had glued up using 6 pieces of 3/4 inch material. We had already laid out the profile for our template and traced it onto the top surface of the MDF. By rotating the workpiece until it was level, we were able to align the bit to set the template. By making marks every 1 inch along the profile, we were able to set the bit at a point on the workpiece and then position the template to match. When the template was properly aligned, we clamped it temporarily in place. We then repeated this step at the opposite end and then checked the travel of the bit to ensure that it followed the line. Here you can see how the stylus or roller on the router base lines up with the template at the same position as the router bit is on the workpiece. Next, we drilled up through the template base to mark the alignment holes on the bottom of the template. A series of holes were already drilled in the template base every 3 inches apart. We marked every other hole in the bottom of the template. We then removed the template and turned it over to drill the mounting holes from the bottom. Two-inch cap screws and wing nuts were used to mount the template to the template base. The head of the screw had to be low enough to clear the router base as it passed over the top. We then removed the workpiece from the machine and cut off the 4 corners on the table saw. For this operation, the bed must be level and raised as high as possible without the workpiece hitting the bottom of the carrier tray as it rotates. To mill the contour, the bit must cut from the side of the stock instead of from the top. We set up and used the spindle motor to rotate the stock without driving the linear drive screw. You can also rotate the stock with the linear drive motor if you don't have this optional spindle motor. The workpiece was then milled round by rotating the stock and manually sliding the carrier tray from one end to the other end while the router followed the template to create the profile. With this design, we're not real concerned with how smooth the surface is because it will be removed when we cut the spiral flats. Next, we engaged the 2x gear reduction set and the 24-tooth drive gear to give us a 15-inch spiral pitch. A microswitch stop was set at each end of the template to control the length of the spiral flats. For this design, we didn't have a spiral cutter long enough, so we used the 2-flute straight cutter instead. Next, we moved the roller out approximately 3/16 of an inch to mill the 6 spiral flats into the round cross-section. We then slid the carrier tray back to the tailstock and engaged the split nut. Then we drove the carrier tray back to the microswitch stop to begin milling the first pass. When the carrier tray hits the stop at the headstock end, we simply reverse the direction of the motor and mill back to the tailstock for a cleanup pass. To index for the next start, we open the split nut and move the carrier tray 10 threads, or 2.5 inches. which is 1/6 of the 15-inch pitch. Again, be sure to turn the motor off before you open the split nut and move the carrier tray. Now we simply repeat the same milling procedure for the second spiral flat. The one thing we found with MDF is that you should really use the dust collector attachment if at all possible. The sawdust is really fine and very messy. After 4 more starts, we ended up with a 6-sided spiral twist that followed the template. Again, remember to turn off the motor drive before you open the split nut to index for the next pass. To mill the hollow spirals, we index the workpiece 90 degrees by moving the split nut 15 threads or 3 3/4 inches, which is 1/4 of the 15-inch pitch, or 90 degrees. Next, we remove the template because the hollow spiral cut is actually straight down the center of the workpiece. We then positioned the router bit at the center of the stock and locked it in place with the router stops. Then we set the microswitch stops for the length of the hollow section. With MDF, we found that we could mill a little deeper with each pass than we could with the flowstone or the wood, but the process is the same. Mill from one end to the other and then plunge down a little deeper and mill back to the beginning until you have cut to the center of the stock. After the first pass, we knew that a dust mask and glasses were mandatory when working with MDF. For the second hollow spiral cut, we moved the split nut 20 threads, or 5 inches, which is 1/3 of the 15-inch pitch. We then repeated the whole process for the third hollow spiral cut. And finally, we changed to a 2-inch diameter core box bit and set clamps on the top rails to hold the carrier tray stationary while we milled a cove at the bottom of the spiral section. This procedure is also shown in the Fast Start training video. For the last sample, we chose a very simple design and decided to use flowstone because of its strength. Again, we used the wooden plug for the live center and the 3-jaw chuck to hold the workpiece in place. The gears were set at a 3/4 inch pitch, and we used a surface planing bit to mill off just enough material to ensure that the outside surface was round and smooth. We then set the gears for a 15-inch pitch and milled from the side of the stock with a 2-flute spiral cutting router bit, just like we did with the contoured profile, but without using the template. Next, we indexed the stock 180 degrees and milled a large flat on the opposite side. This left us with a round piece of stock with 2 parallel flat surfaces that spiraled around the stock. We then indexed the workpiece 90 degrees and set the router stops 1 inch apart. This allowed us to mill a slot 1½ inches wide through the flat sections by moving the router from side to side. What was left was a hollow spiral with 2 wide bands and lots of space in between. The last step was to remove the PVC tubing from the center of this piece and cut it to length. In this video, we've shown you just a few ideas for creating hollow spirals. The possibilities are almost endless. With a little imagination in your woodchuck, you can create projects that others can only dream of. Whether you're a hobbyist who wants to make small projects that have a distinctive flair, a designer who wants to create fine furniture, or a builder who wants to build architectural components that really make a statement, the woodchuck can help put you in a class all your own. At Phantom Engineering, we know that your success will ensure our success. Other videos that are now available will show you step by step how to build projects like the pieces in the southwest bedroom set. Look for other instructional and project videos on architectural components and projects, as well as fine furniture and craft items. If you are interested in the materials that we have used throughout this video, such as the flowstone, Environ, or Corian, please call our customer service department. In addition to training and project videos, Phantom Engineering also produces professional color brochures that you can use to promote your business. Each brochure has a blank box for you to print your company name, phone number, or promotional. Call Phantom today for details and pricing.